Hello friends, welcome to Truth of Physics. Today I will discuss on the three types of polarization: plane polarization, circular polarization and elliptical polarization. So in this video I will discuss that how this type of polarization occurs, that when what polarization occurs. Now in case of polarization we consider only the electric field components, as the electric field vectors, which is also called the light vectors, gives us the sense of vision. Okay, so we are only focusing on the electric field vectors. Now if we consider two components of electric field vectors of light, then these two components denotes such that this is what this is propagating. The first one is propagating along the positive z direction, as this is minus kz, and the E2 component shows us that this light is propagating in the positive y direction. So as this is propagating in positive y and as this is propagating in positive z, so these two, the direction of propagation is not same for the two components. So in this case the superposition of these two components will not produce a polarization. Okay, the polarization will produce only when the propagation is in same direction, that is if this is kz in the two, the propagation direction is same, then only will the polarization will occur when these two will superimpose. Now I am considering that the first wave have a phase angle of phi, suppose theta 1, okay, theta 1, and the second one has the phase theta 2, x cap. Now these x caps are what? These x caps are the direction of the vibration of the electric field component or electric vector, the direction of vibration of electric field. Okay, this is denoted by this x cap, the direction of the E vector, and this kz is the propagation which I have discussed previously. Now if we superimpose these two, then what happens? Then the resultant will be just E1 vector plus E2 vector, and if we know that what will be the answer? The answer will be just a constant, which will be what? Which will be just A1 square plus A2 square plus 2 A1 A2 cos of theta 1 minus theta 2. Now this will be root over, this will be the value of A, and this will be cos, suppose omega t minus kz plus theta. I think that you have known how can I write this. Okay, so I can write like this. So and this will be what? Just x cap. That means what I am trying to focus, that this is x cap. That means these two waves when superimposed, then it will produce a wave whose electric component is in the same direction, right? But now, okay, suppose we have two linearly polarized electromagnetic wave and whose electric field components are like this. One electric field is vibrating along the x-axis and one is vibrating along the y-axis. Okay, now so we just want to see the trace of the electric field component or the electric vector which is vibrating, the trace of the tip of the electric field vector or electric vector. Now you can see the picture in the picture that for to calculate that we have to place a plane, right? As light is propagating in any direction, light is propagating suppose in this direction. So in the perpendicular direction of the propagation, that is if we have a plane to the perpendicular, if we have placed a plane in the perpendicularly in the direction of the propagation, then in that plane the electric field vectors will contain, and in that plane, when we observe that plane, we can easily understand the trace of the electric vector component or electric vector, the vibration of the electric vector. Now for that we have to fix a plane. So we are, for the sake of simplicity, we are considering the z equals to 0 plane. Okay, so for z equals to 0 plane, this term will be vanished. So this terms is vanished and this will be left only omega t plus theta. Now we have some I am splitting this in some cases. Case number 1 is what? Case number 1 is when theta is equals to n pi. Now we know that cos of omega t plus n pi is equals to what? Minus 1 whole to the power n into cos of omega t, right? Now if we put this here, so what will be that? This will be minus 1 whole to the power this will be minus 1 whole to the power n b cos omega t y cap. So when we just divide this to E1 by E2, the magnitudes only, then we will get A divided by B with a minus 1 whole to the power n. That will depend on what we are putting the value of n, that is n equals to 0 plus minus 0, 1, 2, 3 this type, 0, 1, 2, 3 this type. Okay, so when n equals to 0, this will be that is when n equals to 0 means what? N equals to 0 means theta is equals to pi. When n equals to 1 means what? Theta is equals to this will be 0, theta is equals to 0 and theta is equals to pi when n equals to 1. That means theta is 0 means what? These two have same phase, that is in these two waves are in phase, and when theta is to pi that means that these two waves are in out of phase, these two waves are out of phase. Okay, so when theta equals to 0 or n equals to 0, then this will be just a by b, and when in this case that will be minus a by b. Now that means if we plot graph between E1 and E2, that is what we are going to study. The graph between E1 and E2, suppose this is our y axis, that means this is our E2, this is denoting our E2, and this is our x, so this is denoting our E1. So for this case, when theta equals to 0, in this case this will be a straight line like this, but this is not 45 degree. Okay, this is any arbitrary angle theta, which will be what? The tan inverse a by b. This is the value of theta. And when the theta is equals to pi, that means theta is equals to pi, then what happens? Then this will be a this type of thing happen. This is our y axis and this is x axis. This type of polarization is called the plane polarization light. When this type of two lights superimpose, then the resultant will be a plane polarized light, means the electric field component will vibrate, resultant electric field vector will vibrate in a direction just at an angle theta with the axis. Now you should notice that this is not depending on the time, that as time is passing, that when time passes then it does not change, because here it is not dependent on time, here it is not any term of time, so it is independent of time. So okay, now this is case 1. Now case number 2, if we discuss the case number 2, that is case 2, when theta is not equals to n pi. That means for simplicity I am assuming that theta is equals to pi by 2. Okay, so if theta is equals to pi by 2, then what happens? Now if we put this here pi by 2, then we will come that minus b of sine omega t y cap. Now a noticeable thing is that I have arbitrarily chosen this, that b cos omega t plus theta, as we don't know what will be the theta plus, so I have just put here plus sign. In many cases you can see that this is minus theta, so that is also true, because whenever you have given a question or a problem, mathematical problem, then you can easily understand that what I am saying, that you have given the two electric field vectors, then you can easily see that there will be plus or minus in the given question. Okay, so that is not the matter. So here this is minus b, as I have choose the plus sign, so this will be minus b sine of omega t. We know that omega is equals to 2 pi by capital T. Capital T is total time. Okay, now we are considering the time t for many instances, like t equals to 0 for any instant. Now t equals to t by 4, t equals to t by 2, okay, like this. Then what happens? Then at t equals to 0, what happens? If we put t equals to 0 here, so we will get that the Ex will be, that is E1, the component of E1, that is in the x direction vibration, the amplitude will be at t equals to 0, this will be 1, that means A, and at t equals to pi by 4, okay, and Ey will be what? 0. Okay, at t equals to t by 4, what will be? Omega t, means 2 pi by t into t by 4, right? That means this will be cancelled out and this will be just 2, that means pi by 2. So A cos pi by 2, that means Ex will be 0, and Ey will be what? Ey will be okay, Ey will be same, the minus b. Okay, now for t equals to t by 2, that means 2 pi by t into t by 2, that means pi, right? So pi cos pi is minus 1, that means Ex is minus A and Ey is equals to 0. This type of thing. Now we can draw this. This is our suppose y component, this is our x component. So at t equals to 0, A, that means A and Ey is equals to 0, this point. At this case, this will be equal to 0. Now as time passes, that is t by 4, first time is t by 4 I have considered, so, and the second time is t by 2. So after t by 4, what is happening? Ex is equals to 0, that means, and this is Ey is minus b, that means this. Now A and B are different minded, so this is our A, this is our B. Okay, now now t equals to t by 2, that means this. Here what happens? Minus A, this is minus A, and Ey is equals to 0, that means this. So it is tracing like this direction, in this direction, right? So it will be, when we put the other values, then we will get that a circle or a ellipse, as here A is not equals to B, A and B are different, so you can easily understand that here this will be a ellipse. There's this graph will be like this. This will just a ellipse. If the A component is greater than B, then it will look like this. This will be A and this will be B. And if the opposite thing happens, then the ellipse will be like this. Okay. Now, so you can understand that when the theta is equals to pi by 4, theta is equals to pi by 2, then the trajectory of the tip of the electric field vector, the resultant electric field vector, is becoming a ellipse, or a special case of ellipse, that is circular. So this type of polarization, when this is moving in clockwise direction, when it is seen by the observer in clockwise direction, it is coming in clockwise direction, then this type of polarization is called the right circular polarization, using the concept of optical. Okay, this is the convention of optical convention. And in the momentum convention, there are two types of convention. One is optical convention. In optical convention, this is right circularly polarized, and in the momentum convention, it is left circularly polarized. Why? Because when we want to understand the momentum of this, That means the propagation, we have to understand the velocity, that means we have to understand the momentum of the light. That means as here, if you put your left hand, so you will get the direction of the propagation. So this is left circularly polarized using the momentum convention. Now, so I am considering the optical convention. So this is our right circularly polarized light. So the main thing that I want to discuss in this video is that whenever, now this is dependent on time. Okay, what is the equation? This is dependent on time. The two equations are dependent on time. That means this we have considered different times. So the trajectory will be different in different times. That means the trajectory is same, the trajectory is circular or elliptical, but the particle, the motion, I think that you can understand what I am trying to say, right? It is dependent on time, but in our previous case, when the light was plane polarized, it was, the electric field was only vibrating in one direction. So it is not dependent on time, but it is depending on time, and it is, so it is, as this is depending on time, that's why it is what, elliptically polarized. Otherwise it will be just plane polarized light, right? So that means now if you want to understand this in physical sense, that whenever the, as this is in this case, the A and B component moving in, suppose this is moving in x direction, the electric field component, this is moving in y direction. Okay, so these two things start at same instant, that this start to move in upward direction, the electric field component, and this Ey is also start at the same instant of time. That is we call the in phase. These two are in phase, that is the motion is in phase. If you want to understand the concept of phase very conceptually, then I will give the link of the video. From there you can easily understand that. So this is the concept of phase. Okay, but in this case, so this was the case when in the first case, case number 1. So then theta was equals to 0. That means the two waves was in phase, the two vibration was in phase. Means okay, this means, so the elongation in x direction and the elongation in y direction is same. That's why we got the resultant to a straight line. But here what happens, here as this is a phase difference, there is a phase difference between these two vibrations, so the resultant will not, and the phase difference is also, and the resultant motion is also dependent on time. So the trajectory of the tip of the electric field is rotating, right? This is rotating, as this is depending on time, so it is rotating, and that's why we get a type of this type of thing, a ellipse or a circle. So I think that you have understood what I am trying to explain. Okay, so if you really benefited, then subscribe this channel and hit the bell icon to get the notifications of my upcoming videos, and share this video with your friends. So take care of yourself. Thank you for watching.